Well, hello, good morning, good afternoon, good evening. It's really exciting to be here at the Fastmarkets conference digitally, at least. I know that a lot of folks who I have spoken with before and who I work with are at this conference, um, and uh, and definitely other people who I'm very familiar with are here too, who I haven't met yet, and hopefully we have the chance to meet at some point, whether that's digitally today or in person, and or in person in the future. Um, but I hope that everyone is finding the conference interesting and enjoyable so far, um, and um, and yeah, hopefully it'll lay the groundwork for future IRL interactions. Um, so today I am going to talk about the carbon dioxide emissions of making lithium chemicals and why it matters. And I think so. Fast Markets gave me a relatively tame talk title, something like the CO2 emissions of the lithium supply chain, or something like this. Um, I may have proposed that name a couple months ago, but I have changed the name for reasons which I will explain in a minute. I have changed the name to "We cannot build the new energy system using the tools of the old energy system," and the reason is the following. So this is San Francisco, California. Um, this is where I live. So I live just a little bit north of the Transamerica Pyramid, um, and this was my city on the 9th of September, 2020. This is wildfire smoke from the Sierra Nevadas and the Coastal Range Mountains, shrouding my city, my home, in terrible, terrible smoke, and literally turning the sky red. This is real. I think Tesla showed this, exact same image on Battery Day. It was very impactful to me because I have actually moved out of my apartment. I have actually moved out of San Francisco for smoke season. So September to December, it is no longer a habitable period of time in San Francisco. Um, and I've been working in climate and like clean tech, and I've cared deeply about climate change mitigation for my entire adult life, like a decade. And it was always still kind of theoretical, I guess, right? Like I was thinking about polar bears in the Arctic, or the rainforest or the coral reefs or whatever it was. But now it's deeply personal. It's incredibly real, and climate. And I am scared of climate change, and you should be too, because there's nowhere to hide. So thankfully, a lot of us are here because of the lithium-ion battery kind of revolution and the EV revolution, which is fundamentally a response to climate change and an attempt to slow or mitigate climate change. And really that is the foundation for all of the growth in the lithium industry, and again why many of us are here today. So before I try to convince you how we should build a new energy system, I just want to start at like 30,000 feet, or 30 trillion parsecs, or something, some unit of length that's really large. Um, um, this is the Drake equation, which is an equation for calculating the number of civilizations that may exist in our galaxy, with whom we may be able to communicate. I won't go through all the terms, but the one really interesting term to me here is the length of time such civilizations may survive and continue to send communications. So essentially, how does this link back to climate change? So climate change is really an existential threat to like advanced organization of ourselves on our planet, and really, climate change is on track to reduce the magnitude of L for our species. And the reason why is because we're using the atmosphere as a garbage dump for carbon dioxide. It's a very cheap way to handle your waste. And the reason why we did that was because for the last probably 150 years, we've been really focused on our kind of our FC factor. We've been really focused on internal combustion engines and airplanes and TikTok and kind of cultivating nice things for ourselves, which is all good. But with these kind of unintended consequences that we now have to deal with. This is the idea of the end of L is called the Great Filter. So this is actually Elon Musk's pinned tweet at the moment. The Great Filter is the idea that we may not encounter other intelligent civilizations because we extinguish ourselves too quickly. And the reason why Tesla and SpaceX exist is because Elon wants to get us past the Great Filter. So the Drake equation is kind of behind the scenes of all these interesting things happening right now. So this so kind of Tesla adjacent again. This is a quote from J.B. Straubel, the co-founder and former CTO of Tesla, and current Redwood Materials CEO. I didn't know exactly how I was gonna structure this presentation, but I tuned into this Storage X seminar from last week, where JB was talking with some Stanford professors, and he put out this quote that was so perfect. I was literally writing it down as he was talking, and I realized that this quote would be the perfect scaffold to build a presentation around. So let me read you that. Let me read out kind of a paraphrase of what JB said last week. So he said, the embodied emissions of the materials you use to make batteries are significant and need to be understood. If you were to power all your EV manufacturing using coal, which includes the chemicals, it would make no difference at the end of the day. So recall, many of us are here right now because we're trying to contribute to the EV and battery revolution to some extent, which is happening because of our kind of attempt to pass the Great Filter. If we were to use coal to power all of that, it would all be a waste of time. We could all just go home if that were really the case. One thing we did when we built the Nevada Gigafactory was to make it all electric. There's literally no natural gas line, so there's little to no local emissions at that factory. When you weave natural gas through your facility, it makes it much harder to chase it out. The emissions all the way back up to the mine are significant. And when we look at terawatt-hour scales of production, we need to make sure we are not creating unintended consequences as we go through this industrial shift. That is why we are in this situation in the first place, and we need to rapidly remediate that. So these 5 sections were a continuous stream of speech from JB, but I've demarcated them into 5 different sections, and I kind of want to expound each of these 5 sub quotes. So first, the embodied emissions of the materials you use to make the batteries are significant and need to be understood. So I am a founding partner of a partnership with a company called Minviro, which includes Dr. Rob Pell and Dr. David Deek. And at Minviro, we do life cycle assessment of lithium chemical manufacturing and other battery chemical manufacturing, or battery chemical mining and manufacturing. And what we have found is that there is massive variability in the environmental impact profile of chemicals when they come from different types of resources and are processed differently. So there is no such thing as a CO2 intensity of lithium hydroxide or lithium carbonate. There are many, and they vary significantly. So just for lithium hydroxide, from a population of credible or likely to feed into the supply chain in 2025 projects, we found that a clean or low CO2 intensity lithium hydroxide product has about 9 times lower CO2 intensity than a high CO2 intensity lithium hydroxide product. That means that for every ton of lithium hydroxide monohydrate that is used to make a cathode or whatever it is, 9 times more CO2 is emitted when it comes from one source versus when it comes from another source. 9 times. And for other battery chemicals, that ratio is far above 1 for most of them. So for nickel sulfate, it's 5. For graphite, it's 6. The reason why that ratio of kind of good to bad for lithium hydroxide is so high is because of Chinese processing, which kind of encapsulates the high end, and kind of more advanced processes that are being scaled up as we speak at the low end. And the reason why there's been so much focus on lithium is because, the same reason why there are so many juniors in lithium, which is that the lithium-ion battery has the word lithium in it. So there's been more focus on decarbonizing lithium from the get-go. So that kind of makes that ratio high. You'll notice that sodium hydroxide has the lowest ratio of all these chemicals. It's actually 1.6. I rounded up to 2. That's because it's a pretty mature industry. It's like the chlor-alkali industry is gigantic, and sodium hydroxide is used all around the world for many applications. So there isn't massive variability in how sodium hydroxide is made. So there isn't massive variability in its environmental impacts of manufacturing. So an interesting question to ask is, if you were to consider just the chemicals and materials above, what would be the difference in CO2 intensity of manufacturing an NMC811 battery cell, for example, using all of the highest CO2 intensity chemicals versus all of the lowest CO2 intensity chemicals? So if my procurement team, if I was part of a procurement team that decided we're going to find all the lowest CO2 intense chemicals versus another procurement team that decided I'm going to go buy all the highest CO2 intense chemicals, what would be the difference? The difference is huge, actually. So, based on our estimates, which is pretty well triangulated amongst other numbers we've seen, we calculate it's something like 50 or 60 kilograms of CO2 embodied in the manufacturing of that cell per kilowatt hour. So that's, depending on whose numbers you look at, that's like half of the embodied emissions of making the cell. So just by making procurement decisions, you can double the CO2 intensity of making your cell. At 3 terawatt hour per year production, which is what Tesla wants to do in 2030, this delta would be equal to the entire 2019 emissions of Ireland, Switzerland, and Portugal combined, and then some. So think about that. So there's a team of like 10 people in California. I don't know if they're watching. Hey guys, that today have the power to eliminate the CO2 emissions of 3 small European nations in 2030 using only procurement policy. Like, this is not assuming like some technological advancement or some AI or God knows what. Like, this is literally just deciding to buy the lower CO2 intense chemicals instead of the higher CO2 intense chemicals. So that's absolutely wild, and that is that means there's incredible opportunity to decarbonize in those people's hands. Subquote 2. If you were to power all your EV manufacturing using coal, it would make no difference at the end of the day. I don't know if this will be surprising to many people, but with all of this context and all these circumstances, we are actually burning coal to make lithium chemicals to make batteries. This is a snippet from a major Chinese lithium company sustainability report where they discussed how much coal they burn to make lithium chemicals. And there's this really interesting kind of plot here. And by interesting, I mean very unfortunate, really. I mean, essentially what they've done here is presented as this totally statistically meaningless difference in coal consumption from 2018 to 2019 and presented it very deceptively for greenwashing, frankly. And I actually removed the color from this graphic because it was literally green. Um, I, I don't know how to say this in a tactful way, honestly, but like this is insane. This is totally insane, and they shouldn't be doing that, and they shouldn't be burning coal to make lithium chemicals. So I think this is disappointing, and it's just one example of greenwashing in battery chemical manufacturing, of which there's tons. And I'm not going to call out anyone by name because I don't think that's polite, but it's a particularly heinous example. And that Chinese lithium company sells lithium hydroxide to Tesla. So on one hand, you've got JB taking this position that we shouldn't be burning coal to make lithium chemicals. On the other hand, that's exactly what's happening. And of course, it's not coming from Australia; it's coming from China. And this is a very real and relevant impact. So this is from Recharge, which is a European organization focused on the battery supply chain. Based on kind of primordial estimates, they think that only 50% of the emissions of transport can be mitigated with EVs. I'm sure that that's underestimated, or overestimated, I should say. So if the CO2 emissions are much higher than expected, then this energy transition is not going to be very helpful. And there's kind of geopolitical kind of opportunities and consequences here too, which I won't go into too much detail, but I will just leave in my slide. Subquote 3. One thing we did when we built the Nevada Gigafactory was to make it all electric. There's literally no natural gas, so there's little to no local emissions. When you weave natural gas through your facility, it makes it much harder to chase it out. What Tesla did when they built that factory was be very deliberate about chasing out fossil fuels from their processing. And the reason why is because you can decarbonize electricity relatively easily. People with English degrees are building solar plants, like grid scale solar plants, and it's much more straightforward than mineral project development. So if you're delivering energy to your process using electrons instead of heat and fossil fuels, even if the grid is powered by coal today, that can be remediated relatively easily. And they did that using heat pumps. And another interesting idea, which I wanted to throw in there, is the use of mechanical vapor recompression, or MVR evaporators, to shift energy input from a processing flow sheet from heat. You could burn coal to make steam and use that to heat things up or evaporate water, to power, which can be decarbonized, as I said. The emissions all the way back up to the mine are significant too. So just in the context of mining, which literally means digging things up and hauling them off, there are a number of options for electric mining. And if battery metals could be mined electrically, it's kind of like the metals are mining themselves, which I think is kind of cool. But importantly, that mining operation can be decarbonized. Yeah. And then finally, subquote 5. So when we look at terawatt-hour scales of production, we need to make sure we are not creating unintended consequences as we go through this industrial shift. That is why we are in this situation in the first place, and we need to rapidly remediate that. This is a CO2 emission model breakdown for cell manufacturing based on Argonne National Lab data. So when you add that 55 kilos of CO2 per kilowatt hour value to the mining and chemical processing kind of line item, you've more than doubled the value of that line item in this case based on the numbers I'm using. And in fact, it's a huge fraction of the CO2 intensity of making the cell. Electricity and heat for cell assembly can be decarbonized relatively easily. But the embodied emissions of making those chemicals is not necessarily the task of the person making the cell. So battery and EV industry, let this be your canary in the coal mine. So based on our experience of looking at LCAs and doing our own calculations at Minviro, LCAs of lithium-ion batteries are dramatically underestimating the CO2 emissions of your supply chains, and the efficacy of using lithium-ion batteries for reducing CO2 emissions to avoid climate change is not at all guaranteed unless we change the way we mine and process chemicals. decarbonizing cell and battery assembly plants is almost irrelevant compared to decarbonizing battery chemical mining and processing. So the canary is chirping, and the canary is saying scope 3. The canary is saying, look at the embodied emissions of your chemicals, and spend a lot of time talking to your suppliers about their understanding of their emissions. So I put this in here because I've had a number of conversations with people in the lithium industry on the extraction side who think that that presenting their scope 1 and scope 2 emissions is kind of sufficient, and that's all that people care about. And I every single time I have this conversation, I ask, why would battery manufacturers care about your emissions if they didn't care about scope 3, right? So just kind of a little summary for people who don't know. So scope 1 is direct CO2 emissions at the operation. Scope 2 is the emissions associated with the energy you use in the power, and scope 3 is the embodied emissions of the chemicals you use. The scope 3 emissions of the chemicals you use are critical, and they're very significant. Any CO2 molecule that's in the atmosphere because of your operation, you're responsible for. So, sorry, this has been super negative so far. But let me talk about two kind of little case studies that we've worked on to mitigate this issue and to try to reduce the CO2 intensity of lithium chemical manufacturing in particular. One really interesting opportunity for doing this is geothermal lithium. So this is the idea that geothermal brine can be produced from a well somewhere in the world, and it's very hot and potentially high pressure. The energy can be taken out of it to produce power, and in many places that power is very clean. It's 30 to 50 grams of CO2 per kilowatt hour overall, and then to take the lithium out of that brine if it is mineralized. We've done life cycle assessments on these types of projects and have found that they would beat basically all current operations on CO2 intensity. If this is true, and if these projects are technically feasible, make up your own mind. Then buyers need to give these projects offtake agreements, investors need to finance these projects, and engineers need to build them because they're critical. And if you agree with me that the CO2 intensity of lithium chemical manufacturing is important and relevant, then you will agree with me that these projects should be built. Thankfully, there are projects focused on geothermal lithium brines all around the world. I thank Energy Source Minerals and Vulcan Energy Resources for actually funding that LCA originally. They are in California and Germany, respectively. Case study 2, chasing out the CO2 emissions from a sedimentary clay project. So this is kind of a little snippet from a project I'm working on right now with Minviro, in which we are advising a sedimentary clay project on how to develop a process that has minimal CO2 emissions. One kind of interesting takeaway from that project is to realize that when their ore is acidified, they would actually directly release CO2 by dissolving carbonate materials in sediments, which maybe kind of less relevant in a conventional pegmatite project, but very relevant in many sedimentary projects. Excuse me. When sulfuric acid reacts with like a dolomite or calcite, it directly releases CO2. So what's kind of interesting here is upgrading and removing those carbonates is a major focus of some of these projects because they want to reduce acid consumption, which is OpEx at the end of the day. However, that would simultaneously reduce the CO2 intensity of taking the lithium out of those sediments, and to a large extent, actually. So figuring out how to reduce the CO2 intensity of chemical manufacturing is deeply technical, and it's important that it's important that kind of enlightened technical people are really thinking deep about this. And just a little plug: if you're interested in reducing the CO2 intensity of your manufacturing process, contact Enviro today for all of your CO2 mitigation needs. I think it's crazy that we're burning coal to make lithium chemicals and other battery chemicals, and I think we should stop doing it. There's basically no excuse. I don't have time to start a new initiative for the coal-free battery, but if someone else watching is interested, I encourage you to run with it. There should be some kind of certification process to specify, which suppliers are using coal in their supply chain to some extent. I'm not going to expound details right now, but I highly encourage stakeholders and decision makers in this industry to chase out coal from their manufacturing processes for CO2 emission mitigation reasons and PM 2.5 emission mitigation reasons. It is totally bonkers and counterproductive, and not a particularly kind of advanced alien species move to be burning coal to make battery chemicals. So think about that. To summarize, I really want this presentation to be helpful and operable. Just to focus on 3 different types of people in the lithium chemical industry who can make a big impact here. Engineers, you're on the front lines here. It's your job to figure out how to electrify your process and not incorporate fossil fuels into it if you don't have to. And broadly to source low CO2 intense power and to run that process. Don't build your process the same way your employer did it. That's lazy. Revisit first principles to find better solutions. Investors, don't invest in or lend to any new project that would produce lithium hydroxide emitting more than 5 tons of CO2 per ton of lithium carbonate equivalent or lithium hydroxide equivalent. Don't build projects that are dirty. Don't let them get built in the first place, and then the emission will never happen. To be able to understand which projects kind of comply with that criterion, work with independent professional lifecycle assessment practitioners. That can be Enviro, it can be various competitors, whoever you're comfortable with, but use LCA to guide investment decisions, because that's how you separate the green from the greenwashing. And third, probably the most powerful group of chemical industry Homo sapiens, buyers. So if you're buying battery chemicals, you should require ISO compliant life cycle assessments for the manufacturing of all the materials you buy. And you should also set yourself targets for supply chain CO2 emission reduction. For example, just throwing this out here, use it if you like. If you're buying lithium hydroxide monohydrate, don't buy any lithium hydroxide or I guess lithium carbonate as well that emits more than 10 tons of CO2 per ton after January 1st, 2023. That's just an example. It's a target, and it forces you to help new projects with lower emissions get built, and it forces you to make modifications to, for example, remove coal from. It forces your suppliers to make modifications to reduce their emissions, like removing coal from their processing flow sheets. Modify your procurement decision-making process by applying a synthetic carbon tax to yourself. So if you can somehow identify 2 potential suppliers who are willing to sell lithium hydroxide to you for the same price, apply a carbon tax to both of them, and even if be prepared to pay more if the CO2 intensity is much less for a particular supplier. You have to incentivize the right behavior, or else it won't happen. And again, chase coal out of your battery supply chain by not buying any chemical that is made using coal after January 1st, 2023, or whatever date you want to set for yourself. So that's it for me. I really hope that you may agree with my kind of suggestion that we shouldn't be burning coal to make lithium chemicals. I hope that you agree that we should not be building the new energy system using the tools of the old energy system. And I hope that this presentation is helpful for thinking about, like how to ensure that batteries are made with minimal CO2 intensity, and how to make sure that this energy transition is worth it. Thank you so much to all the people I work with who helped contribute to this presentation, and to my